So in 4.6, we're going to talk about inverse trig functions. But before we talk about inverse trig functions, I want us to review a little bit of 4.123, the trig, the unit circles. Okay. All right. So let's do a very basic rundown, right? So you remember on the unit circle, right? Our special angles were pi over 3, pi over 6, pi over 3, and then we had the pi over 4. And notice pi over 6 and pi over 3, those correspond to 60 degrees and 30 degrees. And you remember also that when we were dealing with those, we said that we would draw triangles that look like this. So for the pi over 6 and the pi over 3, we're dealing with the 30 and the 60 degrees, right? So 30 degrees and 60 degrees, and that creates a triangle, remember? So if 30 was our pi over 6 and this was our pi over 3, now I have two angles. One is larger, one is smaller, right? And you remember I said that those correspond to two sides of different lengths. What were the sides? 1/2 and root 3 over 2. Okay, so we have two sizes for angles, two sizes for side lengths. Also, right, when we're considering the sine and the cosine, when you have a triangle set up this way, okay, between the vertical and the horizontal, which one was the sine and which one was the cosine?
The sine is the horizontal.
Other way around. This is cosine of x and sine of x is the vertical, right? So now, if I'm looking for sine of pi over 6, okay, the way the triangle looks is if this is pi over 6, that's the small angle, faces the small side, and the large, this one is root 3 over 2, right? If I'm looking at pi over 3, that's the large angle, faces the large side, and this is 1/2. So if I'm looking at pi over 3, that's the larger angle. It faces the larger side of root 3 over 2. Okay? So here, sine is root 3 over 2. Cosine is 1/2. Here, sine is 1/2 and cosine is root 3 over 2. Yes. Given this, right, if I were to ask you here, let me write that over here. If I were to ask you for sine of pi over 6, right? Here is my pi over 6 in the red. Sine is the vertical, so it's 1/2, right? So what if I were to ask you for the cosine of pi over 3? Here is my pi over 3 triangle. What would be the cosine? 1/2, right? If you can't come up with these on the go, on the fly, here are two triangles. Draw them somewhere and you can refer to them every single time, right? The other one that remains is the 45, 45, 90. So this is where you have pi over 4 or 45. And now both of these sides are the same, which is 1 over root 2 or root 2 over 2. Okay? Yeah.
But it wasn't like on the test when we did this, right? We did this on the.
Okay, so now if we step out of the first quadrant, right? If we step into like the other quadrant. So for example, if I were to ask you for cosine of 2 pi over 3. Now again, I'm looking at pi over 3. Pi over 3, that's my green triangle. And the cosine of it is how much? 1/2. But now I need to fix for the plus and minus, right? So I ask myself, in what quadrant is 2 pi over 3? Is it in quadrant 1, 2, 3, or 4? It's in quadrant 2. Here, cosine is negative, so this is negative 1/2. Okay? So that we need right now. Another one. What if I were to ask you for the tangent of negative pi over 4? Right? Okay, this is a pi over 4. That's my blue triangle. Tangent is one leg over the other leg. In this case, it'll be a 1. But now, negative pi over 4, which quadrant is it in?
Bottom right.
Bottom right, 4th quadrant. Is tangent positive or negative there?
Wait, why is it in the fourth quadrant?
Well, because how would I draw a negative pi over 4? If this is 0,
You're right.
I have to go in the negative direction, pi over 4, so it'll be here. Okay? So tangent will be negative there. All right? Okay, so let's do a couple more. Suppose I'm looking for the cosine of pi over 4. Which triangle is that?
The 45.
The 45. And how much is the value of the cosine? 1 over root 2. Positive or negative? Positive. Now, if I were to ask you for the cosine of 3 pi over 4, which it's still 1 over root 2 because it's a pi over 4. But now, which quadrant is 3 pi over 4 in? Third or second?
Bottom left.
So this is 3 pi over 4. That's 3/4 of a pi. It's the second here, right? So it's negative there.
But if it was in the third quadrant, it would be
It would be positive in the third.
because it's all students take that.
All right, let's do one more. Let's do sine of negative pi over 3. Okay, which triangle am I going to be looking at?
30.
60.
The green one, right? This one, pi over 3. Okay, so how much is the value of the sine? Root 3 over 2. Now, what quadrant are we in?
One.
So I start here. Now I'm going to go negative pi over 3. 4th. So sine is negative there. Okay? All right. So a lead-in to 4.6, where we're going to talk about inverse trig functions. Now, those trig functions, the one that I was just doing on the other sheet, those things are like the math ghosts that'll just haunt you when you least expect it, right? They'll just show up when you least expect it. Like here, in inverse trig functions. Okay, so let's talk about an inverse function like you did in algebra, okay? Back in algebra, or whether it's algebra 1, intermediate, or algebra 2, we said that if a function, if you have a function, in order to see if its inverse is also a function, it has to pass the horizontal line test. Okay, what is that? If I draw like a series of horizontal lines, each line is only allowed to cross the graph once. That means it passes. That means its inverse is a function. Great. This one, will it pass the horizontal line test? No, it'll fail. Parabola will fail. That means its inverse is not a function. Okay? Now, fine. Too bad for the parabola. Let's move on to sine. Look at sine. Will it ever pass the horizontal line? Never.
But I thought if it hits it only once.
Right, but look at it. If it hits, there is no way.
Oh, I was thinking the vertical.
Right. Right. No, it's the wave, right? It will never pass the horizontal line test. So what? Do we just say there is no inverse? Let's go home?
Yep.
Nope. What we do is, okay, we'll just throw away 99% of it, and we'll just take a little itty bitty part that would fit our requirements. So what we do is we restrict it to just this itty bitty part. Okay? Now, it could have been this, by the way, or it could have been here, or it could have been there. The only reason why they take the one in the center is you always want to be as close to the origin as possible, right? So if I only take that blue part, now does that pass the horizontal line test?
Yeah.
Sure does. So that means I can have an inverse. Okay. Well, not me, but the sine function can have an inverse. So if we zoom in, what is the region that we're taking now? This is negative pi over 2 to pi over 2. So let's remind ourselves, what angles are there here that we're talking about? Well, to the left, I'm sorry, let's go to the right first. To the right, I have pi over 6, pi over 4, pi over 3. Sound familiar? And here, I have negative pi over 6, negative pi over 4, negative pi over 3. So now, this is called the restricted domain of the sine function. So the next time you're at a math party and people are talking about the restricted domain of the sine function, you can join the party. This is what they're talking about, right? So that means that inverse sine only exists for these angles. How many total angles are there? 3, 3, 6 plus 2, 8, and then there's 0 in the middle. Let's not forget 0. So 9 total angles. That means when we're talking about inverse sine of x, there are only 9 possible answers. That's it. Only 9. Every single one of your answers is going to be one of these 9 values. If for one of these, inverse sine, you give an answer like 3 pi over 4, is that one of the ones I've listed here? Nope, not an answer. Okay? So you have 1 out of 9 chance that your answer will be correct. Almost, yeah. Yeah, so basically it's plus and minus pi over 6, plus and minus pi over 4, plus and minus pi over 3, pi over 2. And zeros in the middle. We're going to write them again and again and again so many times. So, if we put these on the unit circle, this is the format that I like better. If we put these on the unit circle, we all know that pi over 2 is here, right? And 0 is here. Where is negative pi over 2? On the bottom. Well, it's, if you go in the positive direction, it's pi over 2 pi negative, and positive 3 pi over 2. But if you go in the negative direction, then it's negative pi over 2 here. Yeah. Okay? So, negative pi over 2, pi over 2, and 0. So I just put on the red ones of the ones from my graph. Okay, so how about the purple ones? They go here. Pi over 6, pi over 4, pi over 3. And then I have negative pi over 6, negative pi over 4, negative pi over 3. Okay? So take a look at this. You know why I like it in this format more than in the other format? It's because when we're talking about inverse sine, the only solutions that are possible to us are the ones that I've labeled. So that means if I get rid of everything else, this, okay, is the only space where inverse sine will exist. That's it. So for inverse sine, this is the only ones that we're going to be concerned about. Okay? All right. A little bit of notation. For inverse sine function, we write it as sine inverse of x or arc sine of x. Okay? Huh? Yeah. Yeah. So these are synonymous. So if I say inverse sine of x or arc sine of x, they're the same. They're synonyms. Okay?
on like a quiz question,
Uh-huh.
and you say arc sign,
Uh-huh.
can we use sine -1?
Yep.
Okay.
Knocked yourself out. Okay, so here's how this works. Back in the day, this is how the questions were phrased for you. Sine of pi over 6 equals, and what would you tell me? 1/2. That's right. And you would be correct if you did that. Now, so this is before. Now we flip it. Now I say, what is inverse sine of 1/2? Not 2. Pi over 6. So now I'm asking you, what is the angle for which the sine is pi over 6? What is the angle for which the sine is 1/2? And that's pi over 6. Okay? So do you see how they're switched?
No.
Okay, so this is what I would ask you before. Sine of pi over 6 is 1/2.
How? How do you know that? You just do.
Yeah, because of the. Can you just draw it every single time when you do that?
Yeah. You can draw it. Right now, my main concern is, what does this all mean? So take a look. Before, I asked you, what is sine of pi over 6? And you did this stuff, and you figured out that it's 1/2. Now, I'm going to ask you in the reverse order. So before, you would tell me, okay, this is 1/2. Now I'm going to go in the opposite order. I'm going to tell you, if you have 1/2, what is the angle, the sine of which is 1/2? And you tell me pi over 6. Okay, so basically, for which one of these angles on this half circle will the sine be 1/2? Okay?
Do it for each one.
Right, or if you could just see it, then you could see it. Okay, let's summarize. This is what it looks like. This is what the question looks like. Okay?
What?
I give you this. You are given this. You answer this.
The y.
Right, you answer the y. Now, what is y? Y is always the angle. Okay? So y is always the angle. It's one of these colorful ones. Always. Okay? So these are, so these are the values of y.
Could you use it, you can put it in degrees and not just in radians?
We're going to go in radian mostly. Okay? Now, in order for all this to work, x, you see x? X must always be between -1 and 1. So for example, inverse sine of 2, that's no solution, doesn't work. Because this must always be between -1 and 1.
So you might give us like one of those questions.
Right. And then you'll just say nothing. Yeah, no solution. Okay. Now, one more. If x, this value, if x is positive, the angle is only in quadrant 1, right? So it's pi over 6, pi over 4, pi over 3, pi over 2. If x is positive. If x is negative, it's in quadrant 4, and it's negative pi over 6, negative pi over 4, negative pi over 3, negative pi over 2.
But can it also be in quadrant 1? Because in quadrant,
No.
and if it's positive, it can only be in quadrant 1.
If it's positive, it's only in quadrant 1. If it's negative, it's only in quadrant 4.
Okay.
Your answers cannot be anything other than these 9 values. Okay? So let me ask, yes, they're always, okay, so let me ask you this question. Okay, let me ask you this question. Okay, 11 pi over 6. Which quadrant is it in?
4, 3, 4.
It's in quadrant 4. Because it's just short of a, whatever. It's in quadrant 4. Okay, so it's in quadrant 4 But can it be an answer? No, because it's not part of these 9 numbers. You see that? So only one of those 9 numbers can be an answer. It's 1 and 5/6. That's why. Okay, so let's do an example. Inverse sine of root 2 over 2. What I'm asking is, for which one of these 9 angles is the sine root 2 over 2? Pi over 4. So I just say pi over 4. That's it. Okay. Inverse sine of root 3 over 2, negative root 3 over 2. For which one of these angles are you going to get negative root 3 over 2? So, negative pi over 3, right? Okay, first of all, negative means quadrant 4. Is that right?
Yeah.
So it's going to be, let me do it this way. Negative means quadrant 4. So it's going to be one of these angles. Negative pi over 6, negative pi over 4, negative pi over 3, negative pi over 2. Okay, where do we get root 3 over 2 for the sine? Okay, that's why I was doing this review, right? Where do we get root 3 over 2 for the sine? When it's pi over 3, right? When it's pi over 3, the sine is root 3 over 2. So here, I know it's going to be in quadrant 4, and it's going to be the pi over 3, so it's that one. Okay? When do you get root 2 over 2 for the sine? Well, let me go back to my triangle, shall I? Root 2 over 2 for the sine. Oh, that's pi over 4. Okay, pi over 4. Positive. In the positive quadrant is pi over 4. Okay? C, inverse sine of 2. If you were listening before, and if you remember what I said before, that's no solution. Why? Because this is greater than 1. Okay? What if it was sine of negative 2? Still none, because it can't be less than negative 1 either. Okay. So, this is for the sine, right? So now, let's talk about cosine. Cosine, we do the same exact thing, but you see how cosine looks a little different? So when I restrict the cosine, it is here. So from where to where do I go? I go from 0 to pi, because it would be boring if it was the same thing, pi over 2 to negative pi over 2, right? So now I go from 0 to pi. That means on my unit circle, I'm going to go from 0 to pi, right? In this region. What's the middle? Pi over 2. Okay? So that's the region that I have. Anything below that hemisphere, I don't want it. So that's the only hemisphere I want. That's the only part of the unit circle that I want. So let's talk about the key players over there. I still have my pi over 6, pi over 4, pi over 3. And here I got, then what do I have here? Not negative. Now it's 2 pi over 3, 3 pi over 4, 5 pi over 6. Okay? So now, my solutions to cosine, inverse cosine, are going to be one of those 9. 3 pi over 4 and 5 pi over 6. So, again, y, so it's going to look like this, inverse cosine, x equals y. Y always represents the angle. And x again must be in negative 1 and 1. But now I'm looking at, if x is positive, it's in quadrant 1. If x is negative, it's in quadrant 2. But don't worry, for tangent, it won't be a third one. It'll be one of the ones we've talked about, okay? So let's do some examples, shall we?
Sure, let's do it.
Let's do it. Our cosine negative root 3 over 2. So look here. When do I get cosine root 3 over 2? Oh, when it's pi over 6. Okay, so now it's negative, meaning it's quadrant 2.
It's 2 pi over 3.
Well, it was the pi over 6's, right? The root 3 over 2 is for the pi over 6's. So now let's put it together. In that second quadrant, which one corresponds to pi over 6? It's 5 pi over 6. So here we're going to have 5 pi over 6. Yeah. No, because the cosine is different. Cosine's a bit of a rebel. So if you go to the triangles, cosine, we want cosine to be root 3 over 2. Cosine is root 3 over 2 for the pi over 6. Okay? So we need those triangles with us. Okay, now. Where is cosine 1? For what angle do we get cosine equal to 1? Close. 0. 0. Right? Because here, x is 1, y is 0, so cosine of x is 1. Where is inverse cosine negative 2? No solution, because it can't go past 1 and negative 1.
Wait, can you explain b again? I'm so sorry.
I can't explain b again. So, where do you get cosine equal to a 1, right? So you go to the triangles. Nope, nope, nope. Cosine's not a 1 there. Cosine's not a 1 in the green. Cosine's not a 1 in the blue either. It must be a quadrantal angle, right? So you go to your quadrantal angles. Remember, for cosine, we are looking at this. So we have these quadrantal angles. Here, it's 1, 0, and that's what I want. I want the x-axis, the x-coordinate to be a 1 for the cosine. Okay, so that's why it's a 1.
But then,
I mean, that's why it's a 0.
the other side would be
Right.
We're looking at the y coordinate.
The x-coordinate. You're looking at the x-coordinate.
But wouldn't it be
The angle here is 0.
0?
The angle here is 0.
Oh, because it's just a line.
Right.
If we're doing cosine though, the
Right.
other side wouldn't it just be pi over 0, not negative 1 over 0?
At pi, the cosine is negative 1 and the sine is 0.
So if inverse of cosine was negative 1, it'd be pi.
Yes.
Okay.
Okay. Tangent then. Okay. Tangent 2, we have to restrict it, right? And tangent's kind of easy because it goes, with the leaves. So again, I go from negative pi over 2 to pi over 2. What does that sound like, people? Negative pi over 2 to pi over 2, that sounds like sine, right?
Yeah.
Except, here's the situation now. This is negative pi over 2 and that's pi over 2. Tangent has asymptotes at negative pi over 2 and pi over 2, right? That means we're going to eliminate those 2 points, okay? Because tangent can't exist there. Okay, listen. For sine, what were the angles that we looked at? Pi over 6, pi over 4, pi over 3, and then pi over 2. And here we had negative pi over 6, negative pi over 4, negative pi over 3. It's the same for the tangent, except because at negative pi over 2 and pi over 2, there are asymptotes. We can't have those as our answers. So they're just gone. So you just throw them away. And so you have 7 instead of the 9, right? Okay? So you just have 7 instead of the 9. And again, if x is positive, quadrant 1. If x is negative, quadrant 4. Very, very, very similar to the sine. Okay? So let's do a couple. Where is tangent 1?
It's 0.
You're sure? Okay, tangent, I want vertical over horizontal to be a 1. Okay, red doesn't work. Blue, vertical over horizontal. Yeah, so it's pi over 4. Arctangent, I want it to be root 3 over 3. Okay. Am I going to get root 3 over 3 from the blue triangle? No. How about here? Root 3 over 3 from the red?
No.
From the red, I get 1 over root 3, which is sort of like root 3 over 3. Oh my God, that's the one. No, so it's sine over cosine is tangent. So the halves go away, the 2's go away, so it's 1 over root 3. So that looks like it's the pi over 6, right?
Yeah.
Let's go back here. So this is pi over 6. It's positive, so that's pi over 6. Okay? Now, this is from the book, and this is from another book. But you know what? I think for next year I'm going to take these out because my little charts here, my little circles, I think, this is basically a summary of this entire page here. So we're just going to move on. Move past. Okay? I like my little charts more. And I'm going to have to say, I kind of stole those from another teacher. I know. So I have to give credit to that person. Okay. Compositions of trig functions. What if you have, you know, sine of inverse sine, cosine of inverse sine? What do we do? Okay. Check these out. Sine of inverse sine, they undo one another.
So it's just 1/2.
It's just 1/2.
So it's like g of x.
Yeah. Oh my God. It is not like g of x. It is that, right? It is that. Thank you so much.
So, wait, can you do that one?
Yep.
Again?
So then,
Sine and arc sine go away.
so then
That's
the
so-
other one
that's
is
so nice.
5 pi over 2.
Yup.
And then that would just be
Negative 5 pi over 2.
yeah,
Okay, now that you're having so much fun with that one, let's go with ones where they're not the same, guys.
No.
Right? Okay. So take a look here. I have a sine and an inverse cosine of 4 over 5. Okay. Literally,
you find the inverse.
divide and conquer. Divide and conquer. I go with the inside. I ignore the sign. Draw a triangle for this. Here is a triangle with an angle theta. What that stuff in the red is telling you, there is this mysterious angle, the cosine of which is 4 over 5. It is, but yeah. So the cosine is 4 over 5. That means adjacent over hypotenuse is 4 over 5. Okay? Find the missing side, 3. And then go back. Okay? Go back to the outside. We divided, now we're conquering the outside, right? The outside sine of theta, 3 over 5. That's it. Right? Yes. 1, 2, 3. Let's do it again. I'm going to keep the same color coding. Divide and conquer.
So sine of 1.
Except that one is not a triangle.
Yeah.
Okay.
Line. Right? I'm sorry.
So this one, when you have sine of 1, that's a quadrantal angle.
Is it just 0?
Where is sine equal to 1?
0.
You sure?
Yes.
I'm pretty sure.
So at 0, it's x equals 1, y is 0. Is sine 1 there?
I got it.
No.
Where is sine 1?
Pi.
0 and 1. Negative 1 and 0. 0 and negative 1.
0.
Sine is the y value. Where is the y value 1?
Pi over 2.
Pi over 2. This is the one. So what's the tangent there?
The tangent of pi over 2.
Right? How much is it though? Tangent. Sine over cosine. 1 over 0. Undefined.
How? Oh, wait.
Because we're at pi over 2 up here.
Yeah.
Tangent is 1 over 0. Tangent is y over x or sine over cosine. So if this is cosine and if this is sine, 1 over 0 is undefined. Okay, so before I let you go, this is the homework for next time, right?